All right, good evening. Welcome to lesson 12.1. That's correct, 12.1. This is the lesson that immediately follows the 10.6 thing on coordinate graphing. We wrapped up the first part of chapter 10, the part that we're going to do on integers, and then the very next lesson that we're going to talk about today is lesson 12.1. So you're not in the wrong place. This is course 1. This is a continuation of the chapter 10 stuff we have been doing. And I am here with my good friends, Kate and T, and they're gonna help me help you learn how to solve two-step equations. Okay, and so in solving two-step equations, it's going to be an awful lot like solving one-step equations. Okay, with just one extra step put in. That's it. No big deal. The step is even going to look familiar. All we've got to do is decide what order to do the steps in, and then everything else should look really familiar with what we've already done. So let's start out by doing a little review. Sound good?
Yep.
Okay, so I'm going to write down a couple of quick equations, and we're going to solve them, and we're going to practice doing just some really basic one-step algebra. All right, so let's start with one where x plus 7 is equal to 11. How do I get, so the two steps that you're supposed to remember, let's go over here to the steps. Step 2 and step 3 are the ones that you use when you do one-step equations, and they were opposites. Remember that? How do you get rid of something? You do its opposite, and balance, you have to do it to both sides. Remember that? Okay, so backing up, what do you do to get rid of, to get the x by itself, what do I have to get rid of?
Oh, 7.
Get rid of 7. What am I doing with it right now?
You're adding.
I'm adding it. What's the opposite of adding?
Subtract.
Subtract. So subtract 7 from both sides. That does the opposite, and it keeps balance, doesn't it? You get to do a little fruit ninja there, and you get x is going to be by itself now, which was the goal. And what is 11 minus 7?
4.
It's equal to 4. You check your answer. Does 4 plus 7 equal 11?
Yes.
It surely does. Good job. All right, suppose we have x minus 7 is equal to 14. All right, what am I doing now to the x?
You're subtracting 7.
Subtracting 7 from it. What's the opposite of subtracting 7?
Adding 7.
Adding 7. But if I add 7 to the left, what do I have to do to the right?
Add 7.
Add 7. Fruit Ninja, this time I get x equals 21. And sure enough, if I take 21 minus 7, does it equal 14?
Yes.
It sure does. Go ahead and put a check. All right. What about this one? Suppose I have 3x equals 24. What am I doing to the x now?
Multiplying it by 3.
Good. What's the opposite of multiplying by 3? Dividing by 3. All right. I'm running out of colors here, so we'll go back to blue. So let's divide both sides by 3. We show that by two little mini fractions like that. Again, we're going to fruit ninja. We always fruit ninja. So 3 divided by 3 is 1. 1 times x is just x. Just like always. If I do this right, with a one-step equation, after I fruit ninja, I should always get the variable by itself. And what is 24 divided by 8? Whoops.
I know what I say the wrong answer.
Okay, that was a little Freudian slip there. What is 24 divided by 3? And
8.
The answer is 8. All right, sorry about that. I had the answer on the tip of my tongue, and it apparently just slipped right off the tip of my tongue. Sure enough, does 3 times 8 go back to the red equation? Does 3 times 8 equal 24?
Yes.
It surely does. We'll put a check mark. What's the last type of equation I haven't shown you yet? We've
Division?
added, subtracted, multiplied. Yes, division.
So
All right, so again, let's go with the red. Okay, so let's start with x over 5 equals 12. All right? What am I doing right now to the x?
Dividing it by 5.
What's the opposite?
Multiply by 5.
Okay, the way we show multiply by 5 is I put parentheses around it, I put a little 5 dot on this side, but if I multiply the left side by 5, I have to multiply the right side by 5. Okay? On the left side, 5 and multiply by 5, divide by 5, they fruit ninja, and you're left with just x. No coincidence there. We're getting kind of used to that.
Yep.
And what is 12 times 5?
60.
Good, 60. Is 60 divided by 5 equal to 12?
Yes.
Surely it is. So that is a quick review. Now, those are called one-step equations. Why? Because you had to do one step to get the value of x. And I know that I picked some pretty easy integers, and so for the most part, I think you probably could have done a lot of those in your head. But the same rules apply for when I have negative 18.4 and I have to add 7.2 to both sides. Now, you might have to, trudge out the integer stuff that we just did with the 3 commandments and adding, subtracting positive and negative numbers. But the algebra, okay, the underlying pre-algebra, the algebraic solving of the equations is the same. All right. So let's continue. Let's go back to those steps again. So we had from back when we did one-step equations, we learned about doing the opposite to get rid of something. We also learned about balance, where we try to keep whatever we do to one side, we have to do to the other. Now, you have seen the other two steps. I've written them down for you before. We just haven't had to practice them because we've never had need for them now. But now we're going to pull them out of the storage, and we're going to employ them. So step 0 is simplify. Okay, and sometimes we have to simplify equations before we can even start solving them. So I'm going to go ahead and throw that out there. I'm going to go ahead and throw that out there. Again, this is a little bit of foreshadowing of what we're going to do next with equations after we learn to solve two-step equations. Okay, but that's not really for right now. It's just step 0. It's what you would do first. Okay, now you remember me saying almost something exactly like that. What order do I take apart a two-step equation? Well, I just write down the word PEMDAS, but I write it down backwards. And if you write PEMDAS backwards, it's going to be SAD MEP. Sure enough, double check it. Please excuse my dear Aunt Sally. If you go backwards, it's PEMDAS, right? Okay, so SAD MEP. Okay, I'm not sure what a MEP is, but whatever it is, it's SAD. All right? Okay, SAD MEP tells us the order that we are going to go in. And I'm going to take that arrow out because we're going to go in the correct order. We're going to get rid of subtraction and addition first. Then we're going to get rid of any division and multiplication. Then we're going to get rid of any exponents, if we have any, and then we're going to get rid of parentheses last. So this is a lot like that problem-solving strategy that we saw both in Course 1 and in pre-algebra, where you work backwards. And how do you work backwards? You start at the end of the problem, you work backwards, and what do you do each step? You do the opposite. That's exactly what we're going to do. So let's take a look at an equation that is a two-step equation. All right, I want you to look at equation A. Equation A, you have a C, a variable C, and the variable C is being multiplied by 5, and then we're also adding 15, and the ultimate answer is going to be 30. Now, if you just think about that pretty quickly in your head, you can probably figure out what the answer is. Can anybody do that? What is it?
3.
That's correct. It is going to be 3. Let us practice how we show our work for when the numbers aren't nice and neat, like 5 and 15, 30. I gave you multiples of 5 here, right? What if it was 5.2 minus 15.6 equals negative 31?
No.
You probably wouldn't have done that one in your head, would you?
No.
So let's learn how to show our work very carefully so that when they get harder, we've learned the basic fundamentals of how to do these, okay? So what does SAD MEP tell us to get rid of first? Well, what am I doing with the 5 and the C?
Multiplying.
Multiplying. And what am I doing with the 15?
You're adding.
Adding. So SAD MEP, I'm going to put it up here in the corner. SAD MEP says to get rid of subtraction and addition first. So let's get rid of the 15 first. How do I get rid of a positive 15? What's the opposite of adding 15?
Subtract.
Subtract 15 on both sides. Why on both sides? Because you have to keep balance. You get the Fruit Ninja just like before. But now, instead of getting C by itself, you get 5C is left over on the left. And the right, 30 minus 15 is 15. Now the second step, we get rid of division and multiplication, correct?
Yes.
Okay, so now 5 times C, the opposite of timesing by 5 is divide by 5. And sure enough, Fruit Ninja, and you get C equals 15 divided by 5, which, as we already know, T figured out was 3. That's it. Okay? So it's 2 steps. It's exactly the same kind of steps we did before, except there's 2 of them. All right, Kate, look at letter B. What will I get rid of first? The divide by 5 or the plus 7?
The 7.
Why?
Because it's SAD MEP, so addition.
So addition is going to go away before division does. And how do I get rid of a plus 7? Both of you? Subtract 7 where?
On both sides.
On both sides. If I do that, this Fruit Ninjas, I get A divided by 5 equals 12 minus 7 is 5. And now, T, how do I get rid of a divide by 5?
Multiply by 5.
Multiply by 5. The way I show that is I put parentheses around both sides. And I put a 5 dot here, and I put a 5 dot here. Multiplying and dividing A by 5 will cancel out, and I just get A, and 5 times 5 is 25. Now, let me go back, and we're a little neglectful here. We kind of rushed that right ahead. We didn't check these 2 answers. So let's put 3 back into A and see if T's answer was right. I think we can quickly see that 5 times 3. By the way, when you're checking, you're doing normal PEMDAS. So you do 5 times 3 first, which is 15. You add 15, you get 30, it checks. So put the check mark in here. And for the second one, put 25 in. 25 divided by 5 is 5.
5.
5 plus 7 is 12. Again, it checks. Okay, that's it. All right, we're going to let you see if you've got this. So what we'd like you to do right now is either on a blank sheet of paper or maybe on your daily quiz log for tomorrow, go ahead and write down the equations for C and D, pause the video, solve those two equations, check them either on paper or in your head, and then if you think you've got them right, go ahead and resume the recording and see if we get the same thing. Okay, pause the video now. All right, everybody, welcome back. All right, let's take a look at what you should have gotten here. What you should have done on C is you should have added 1 to both sides. Why add 1? Because SADMAP tells me to get rid of the subtraction first. If I do that, I get 3n is equal to 18. Now divide both sides by 3 to get rid of the times 3, and you'll get n equals 6. If you plug that back in, 3 times 6 does equal 18, minus 1 is 17. It should work. So you should have got n equals 6 for letter C. And for letter D, what are we going to do first? We're going to get rid of the
12.
The positive 12 by subtracting, sorry, that doesn't look right, subtracting 12 on both sides. Now, here's where you get to use your integer stuff. Okay? Positive 12, negative 12 cancels out, you get 7h. Here we have a negative 9 and a negative 12. You could think of that as subtracting, but a better way to think of it is adding two things with the same sign. Same sign, we're supposed to find the sum. Okay, 12 and 9 is 21. They're both negative, so we're going to keep the sign of, well, really the larger value, but really both of them by the third commandment. I have h times 7, so divide both sides by 7. And again, I get to use one of my new integer rules. What's a negative divided by a positive?
Positive.
No, it's a negative.
No.
Because the two things have different signs. So instead of taking the difference, different signs is like a difference is like a minus. Minus is like a negative. So we get a negative 3. And sure enough, if I put negative 3 back in, 7 times negative 3 will equal negative 21. If I add 12 to negative 21, if I owe $21 and let's say I make $12 doing somebody a favor and I pay them back that, I still owe them negative 21 plus 12 would still leave me with a total of negative 9. I still owe $9. Okay, that's it, guys. We're a little over 10 minutes, and I apologize for that, but this is kind of the heart of the beginning of pre-algebra next year. You're going to start with adding, subtracting integers in the 3 commandments, and then you're going to go right on into solving equations kind of like these. So we're getting a head start for next year's pre-algebra class. So good job. If you have any questions about this, be sure to ask them in class, but otherwise I'll see you and we will practice solving 2-step equations tomorrow. And thanks to Kate and to T. We'll see you tomorrow.
Bye.